talk has a very long title, which is an HTTP request is just 3 TCP packets on top of each other in a trench coat. And I will just say something brief about this image that you're seeing. If you recognize the TV show that this is from and know the names of the characters, please come talk to me during the break. Not to talk about TCP or Node.js, I just want to be your friend. And so my name is Yonatan Mevorach, and I'm from Wix, and that's going to be relevant later on in the story. So today I want to talk about TCP, which I'm sure if you came to a Node conference, you're probably web developers, you work with Node.js, you're familiar with it. But if your experience is anything like mine, I was pretty far along in my career without never having the chance to actually write and try TCP, with my own code and with my own fingertips. Like, obviously, I learned that it was there. I know that it works behind the scenes of HTTP and other protocols that we use every day, but I never got to try it out for myself and understand what this means for real. So this is what I want to try to accomplish in this talk today. We're going to see how HTTP and a bunch of other protocols that I'm sure you're familiar with are actually built on top of TCP and later UDP. And we're going to try to build this ourselves so we can get a better understanding of how it works. And what's going to enable us to do that is the fact that inside Node.js, we have one of the built-in modules. You can just start using it. You don't need any external dependency, which is the net module, which exposes an abstraction on top of TCP, which we can use. So the way that's going to work, we're going to go through these different protocols and tools. For each one, we're going to see a sequence diagram to understand the communication protocol. Because we want to keep things practical, we'll see a Node.js code sample. And I will also try live demos, so that might work or might not. We'll find out together. OK. So to dive in, I first want us to experiment with working with TCP directly. And one of the easiest ways you can do that is using a utility, a CLI, which is available in pretty much every Unix or Linux environment, and also in your Mac, which is called Netcat, or NC for short. And we're going to be able to use that in order to see the properties of TCP, which I'm sure you're familiar with, the fact that we can open a long-running connection that stays open for a long time, and also so that it's bidirectional, so both parties can initiate sending data. So to do that, we're going to use Netcat. So on one side, we're going to write Netcat that we want to start a TCP server on this port. And on the other side, we're going to use ncat again, and we say we want to connect to localhost. Obviously, this could be a remote machine, but right now we're just communicating over localhost. And what should happen now is that if I write something here, hi, it shows up on the other side, and I can decide to write from this side, and it will show up on the other side. So in order to understand how this works and to learn how we can do this in Node.js, what we're going to do is we're going to re-implement Netcat, or the behavior in this demo, using Node.js. So let's demo the same behavior, but this time the client is going to be a Node.js server that we wrote. So I'll just write Node client.js, and it's going to behave the same. So I can write on this side, and it'll go to the other side, and so on. So let's see the code of how we can do this. So we're using the net module, as I mentioned. We're calling net connect, which connects to a TCP server. We need to specify the IP or the domain, or localhost in this case, and the port that we want to connect to. And then we can add an event handler for what to do when we get data over this connection. So this is client on data. And then for the sake of this demo, what we want is we want to show it in my terminal. So we send that data to the process std out so we can see it. And similarly, so that when I type stuff, that will get sent across the connection, I'm binding the process std in and saying when I get data there, write it to the client, the TCP client. So, and that's how it's working. So now let's try the reverse. Now let's have the client be Netcat again, but this time the server is going to be the server.js that we wrote, and it's going to, and let's use Netcat to open up the client. So when I write something here, it will show up on the other side. And in fact, I can even open up a different client. So it says, hi, I'm Bob, and I want to greet Bob back. What will happen now is that hi, Bob is sent to both the clients, right? Because I'm not handling anything in my code, which we'll show in a minute, that takes care of saying, no, I want to send these messages to these clients. And this is something that throughout the demos today, I'm only going to show code samples that kind of work, assuming only one client. So keep that in mind. You would need to make things a bit more complex in order to deal with multiple clients, which is what will happen in a real-world scenario. So now let's see the server code, how we do that with the net model. We call net create server. This creates a server, and we get a reference. We get a callback that will be called whenever we have a new client connecting to our server, and we get a reference to the socket. We'll define the socket in a better way later on, but the socket represents the connected client. And what we can do is very similar to before. We can bind to the data event of the socket, which means that we got message from the client that's sent to our server. In this case, we bind that to the process std out, and again, binding the process std in and writing that to the socket, so when I write things in the terminal, it will actually get sent across. And the last thing that I need to do to start the server is to call the server.listen and say the port that we want to open, and that's where we're waiting for connections. Now, the title of the talk, as I mentioned before, that basically HTTP is just built on top of a TCP. So let's see an example of that. And what I'll do now, let's close these. Okay, and put that on the right-hand side. Put this on the left-hand side. Now, I don't need a unique server because I want to deal with HTTP, right? The same server that we already showed, a generic TCP server, can just work for the sake of communicating with HTTP. So I'll just spin up the same server. But instead of making the request with netcat, now I will go to a web page on this server, which means it will, that's interesting. Even before I hit enter, the browser is already making this request. And now I can see that the content that I got over the TCP connection is the HTTP request. And in order to return an HTTP response, I don't have to do anything unique other than the fact that the content that I write needs to match the HTTP protocol. So if I write something that looks like an HTTP response, then that will show up, and it will be a valid HTTP response, and the browser can render that. And we're actually, when we're thinking a lot about HTTP, we tend to think about like a request and an immediate response that we buffer. But actually, here we can see that because I didn't close the connection, the response stream is still waiting, and I can keep writing stuff, and it will wait until I'm done. So that's HTTP on top of a generic TCP server. So let's unpack what we saw and what we learned about the net model so far. Here's what we didn't see. Even though I said it's an abstraction layer in Node.js for handling TCP, I didn't have to deal with the stuff that we think about when we talk about TCP, right? So the TCP handshake, the individual packets, we have no way of seeing them, but it's just been taken care of by the OS for us. So one of the things that make the characteristics of TCP is we can get the packets out of order, and we need to reorder them in order. The packet sequencing, all that is happening for us. And also the stuff that's happening below the TCP layer or by other protocols, so DNS resolution, IP routing, all that stuff is handled for us. So that's great. But think about what we didn't see, not because it's happening out of the box, but because it's not happening at all, and that's encryption and authentication. So that stuff is typically handled by things that are higher up in the levels compared to TCP. So if we decide to go with TCP directly, we need to take care of those things ourselves. And throughout the talk, I'm going to not handle encryption and authentication, so please don't copy-paste this code to production. Okay, so I mentioned before that we get this mysterious beast, which is called a socket. What is a socket? So a socket, we identify a socket based on an IP and a port. And it's called a socket because it's meant to convey that we're creating these connections by plugging into sockets which are available for connection. And that means that in my server, whenever I get a new connection, I can know I have two parties, right? The remote party and my server, the local. And for each one, we have the address, which is the IP address, and the port. Cool. So now let's talk about a different protocol, not HTTP, which I'm sure you're familiar with. WebSockets, you probably use it every day, right? We're using ChatGPT, so that's working on top of WebSockets as well. So let's try to implement that ourselves. There's a very popular NPM library called Socket.io that a lot of people use, but it's more fun to try to build it ourselves. So let's see a demo of this in action. So I will call this server, which we'll see the code for in a minute. And then when I go to this web page, this server is configured to whenever it gets a message to reply with the message you said and repeat, kind of parrot what the client wrote. So if I write hello, I will see it on this side, and the reply from the server will be you said hello. So the protocol that is meant to establish a WebSocket connection is built on top of HTTP. Because back before, when WebSocket was new technology, we had to find a way to establish this, this connection with existing servers that may or may not yet support WebSockets. So it starts off as an HTTP request, but we're giving the server the hint that we want to transition or to upgrade to a WebSocket connection by saying that we're sending headers that say connection upgrade. The type of upgrade we want is to a WebSocket, and according to the spec, we need to send this sec WebSocket key. Then the server needs to do a SHA-1 over the key and a GUID, which we'll talk about in a minute, and reply, okay, I know what you're talking about. I know the secret handshake. So the way I tell the client that, that I'm in is to reply with 101, switching protocols and passing these headers along with the accept key. And now once both parties are opted in, we can create just a TCP connection that we can send data over. And the neat thing is that we don't have to create a new connection because a TCP connection was already established to handle this HTTP request, so we just reuse that connection for the long-running back and forth. And the only requirement, according to the spec of WebSockets, is that you have to encode and decode the messages or mask and unmask them in a certain way. This is not encryption, so don't think that if you're doing this, your data is encrypted if you don't want somebody to see it. But it is something that you have to do according to the spec. So let's see the code. I'm not using the net module because I have to start off as an HTTP request. So I'm using the HTTP module. And I'm listening for an upgrade event, which happens when there's an upgrade request. And I say, okay, and also, by the way, notice that I'm getting the socket. So even though I'm not using the net module, I am getting the same type of socket that we get when we import the net module. And then I say, okay, I only care about WebSocket request. That's what I'm expecting. And then I need to do this dance with the SHA-1 and composing the accept key. So I do that. I take the WebSocket key from the header. And then I need to pass it to the SHA function with this GUID. Now, normally when you see a GUID in a code sample in a talk, it's just like a placeholder for something that we need to come later. But this GUID is actually, you need to pass this exact GUID. So this is the first time that I'm seeing something like this. This GUID is a magical GUID that's mentioned in the WebSocket spec, and you need to use that specifically, which is interesting. And then you return these headers as an HTTP response using the socket. And then, just like before using socket on data, we can start getting messages from the client. And the only requirement is that we decode them and encode them according to the spec, which we won't go over. It's very tedious byte shifting code, but you can read it later. And this is just how the WebSocket spec tells you that you must encode and decode the data. And just to, again, as before, if we want to start a server, we need to call server listen and say which port we want to start listening on. Awesome. So now let's move on to something else which you're probably familiar with, and that's SSH. Not this one, sorry. So SSH, the one you're probably thinking on, that's a protocol that lets us start a new shell session on a remote machine. And the first S there is very important because we want this to be a secure session, right? Even though we're communicating with the machine on the other side of the world, we still want nobody else to be able to like log into our server and run commands and read our private data. So just to get ourselves familiar with the basics of how this can work, we're not going to re-implement SSH. We're going to implement SH, which is SSH without the security. So don't do this at home. And one of the ways we can experiment with this is we can use netcat again, start a new netcat listening server, and we pass this -e command, and then we give it a command that we want it to run. And what this will do is whenever there's a new connection, it will start this process that we ask it to and pipe them. So that means that whenever data is coming through the connection, pipe it to the process you created. Whenever the process has an update, pipe that back to the data connection. Or at least that's what I think this command does, because I tried to run it on my machine and it was blocked. Because this command is very popular among hackers who gain access to your machine. And in fact, and I swear this is a true story, I was working on this conference talk at 4:30 in the morning, and I ran this command, and 3 minutes later, somebody from the Wix SOC team thought I was being hacked, so they reached out to me on Slack and asked me if I'm the one who's doing this or not. So don't do this at home. So let's see how this will work. We're going to be able to get something like this working because we're going to do it in Node.js. So the plan is whenever there's a TCP connection from a client to the server, when the new connection is open, we're going to spawn a new shell session, pipe the socket and the output-input of the shell session, so that when somebody types like a shell command like ls on the client, they will get back the response as if they're using the shell session on the local machine. So let's do that now. So we'll there we go. So I will run the mini non-SSH SSH server, and then using netcat again to join it. What's going on? Wait. What did I do wrong? Oh, I think I'm missing. Bup. Okay, here we go. And now if I write ls here, I'm actually reading the files that are, well, I'm doing this over localhost, but reading the file on the remote machine, supposedly. And I can even like read files. So that's cool. All right. So how do we do this in code? We use the net module again. We create a server. We get the socket. Whenever there's a new connection, we spawn using child process, which is another built-in module in Node.js. We spawn a new process, which is a shell session, and we pipe them. So before we showed the syntax of a socket on data write to somewhere else. There's a shorter way of doing that using pipe. So by saying socket pipe shell std in, that just means when there's data on the socket, send that to the shell std in. And likewise, when there's std out on the shell, pipe that to the socket. Then dealing with exiting and starting the TCP server. Cool. Now, if you want to create a valid implementation of SSH using Node.js, you can totally do that. This is a package called SSH2, and it's available on NPM, and you can use it to use programmatically a completely spec-compliant SSH client. And it does this without many dependencies, only 2 dependencies, and they're related to the encryption and the authorization, so they're like cryptographic libraries. But the actual network aspect of it is built on top of the net module, just like we showed here today. Okay, so let's see another example. This is not like a real protocol. This is not like a standard, but this is a tool that many developers use, and there are others like it, but this is kind of the most well-known one. So this is called ngrok. And this is a tool that helps me when I'm developing something locally that I just want to test out. So I have a local server running on my machine, and I want to make it available over the public internet, like if I want to test like a webhook or something like that. So, and I don't want to do this by opening up ports on my network. I don't want to get like a static IP address or actually deploy it somewhere where there's a domain. So I just want to expose my local HTTP server that I'm testing things on to the public internet. And people use ngrok for this. So we're going to implement a very basic single client-only version of ngrok. And the way this will work, the way we're able to do this magic where our machine is suddenly exposed on the internet, is that according to the basic firewall laws, it's okay to create a connection from your machine to the public internet, right? But somebody from the public internet can't connect to your machine. So we're going to take advantage of that fact. So before we start actually getting the HTTP request from the public internet, we're going to make a TCP connection from the tunnel client running on my local machine to a public server of a service like ngrok and create a connection between the two, and we're going to keep that connection open. And then when there's an actual HTTP request that we want to proxy over to our local server, it's going to go from the browser or the external service to the public tunnel server. That's going to pipe that over the tunnel between the public internet and my local machine. And then on my local machine, we will forward that to my innocent HTTP server, which is not even aware that all of this is going on. And likewise, when there's a response, it's going to be sent back. So let's see a demo of this. And up until now, I only showed like stuff, even though we're talking about networks, I only showed stuff working on localhost. Now I will actually try to demo this between my local machine and my server in the US. Let's see if it's working. So first let's go to, okay, so this is the local server that's running on my machine. And now if I go to my server, which is in the US, I'm actually seeing the same content based on this approach that we just showed. So now I'm going to close out because I don't want anybody to connect to my local machine. So now let's see the code for this. So now we need two scripts. One script is going to run, as we just showed, it's running on the public internet. So this was run on my server in the US. So what this will do is we need, one way to achieve this is using two TCP servers. So we need two ports. The port 7000 is going to be used as the entry point for the HTTP request. Like we showed before, we don't need to really start an HTTP server, because as long as we're not trying to read it as an HTTP response, for us it can just be a TCP server. And the tunnel port on port 9000, that's the one that the client has to connect to first in order to open this connection. So when we get a connection on the public port, we don't do anything. But when we get a connection on the tunnel port, we save a reference to that tunnel socket. And so when a request actually comes in over the public port, we again use pipe to pipe the data from the public socket to the tunnel socket. And when we'll get a response from the tunnel socket, we'll pipe that back to the public socket. And this is the script that's running on my machine. I need to be aware of Yonatan dev, that's the remote server that I'm trying to connect to. The tunnel is expecting connection on port 9000, as we showed before. And port 3000 is just the local server. It doesn't have to be written in Node.js. It can be in any language. That's the one that we're doing all this for, that we're trying to expose on the internet. So I'm creating two TCP connections. One is the tunnel connection to the public internet, and the other to the local HTTP server. But again, I don't need to deal with the fact that it's HTTP in any way. And then again, I'm using pipe, so piping the data from the tunnel to the local server and the response from the local server to the tunnel. And the reason that I'm doing end false here, that just means normally the out-of-the-box behavior that we get from pipe is that if one side closes the connection, we close our connection as well. And end false just means I'll do it myself. So let's talk about the sibling of TCP, which we didn't talk about so far, which is UDP. We also have a built-in module in Node.js for dealing directly with UDP. This is called the DGRAM module, because UDP stands for User Datagram Protocol. And the nice thing about this one is that it does give you like a lower level control, as opposed to the TCP, where it was kind of underwhelming, where we don't get to work with the raw individual TCP packets. Here we can have more granular control and send like individual packets. And the way we're going to demo that is using a protocol which works on top of UDP, which is DNS, right? What we use for domain name resolution. So let's demo it first. What this will let me do is just use a DNS client. It will show the code for it in a minute, and then I can pass any host name, and it will tell me the IP address. So let's see how this is done. And the neat thing here is that here we actually have to work with binary data. So we're going to see in a minute we have to actually compose the binary data in buffers. So first we take the domain name that we want to look up, and we need to create a query, which is a packet that we'll need to send based on the structure that we need to work with when we're working with the DNS protocol. And in most protocols, we have the concept of like a header, a metadata about the request that we first need to pass. And you can see I'm using buffer directly here to actually set these bytes. Most of them are zeros, but the one that I'm changing are saying this is a standard query. We're asking one question about one domain. Then I have to encode the domain that I'm asking questions about. So we don't use the human readable form with example.com. We need to split this, and then we say for each part, we need first to create, we tell it first the size of that part. So like in the example is 7 bytes, so we send 7, and then the bytes for example, 3 bytes, etc. And then we have to add another sort of metadata about the request. We're looking for an A record, and we're asking about the internet class, which seems to be like the only one. So I guess this is like a relic from older days. And then we're concatenating all these bytes together and actually composing the packet that we want to send. And the way that we send that is calling dgram create socket, UDP4, because we're working with IPv4. And we're doing socket.send, sending that query packet to port 53, which is the port that we typically use for DNS, to the host is 888, which is the Cloudflare DNS server. And Google, sorry. Thank you. Somebody's paying attention. Then calling socket on message, and then we're getting back the response, which we parse. And here we're doing it in kind of a hacky way. We're just taking the last 4 bytes from the packet which represent the actual IP. So I hope that you learned that TCP UDP is fun. You learn how things work, and maybe you'll consider doing stuff directly with these abstractions in your next project. And thank you very much.